Now for this third set of integrals, we're going to explore different things like some special substitutions that we can do, and also when to use some identities to work with some special trigonometric integrals. So first, let's see this integral here, square root of x times exponential e to the square root of x. Normally, this will look like a product for parts, but the problem is that when you do square root of x, then it's very easy to rearrange with the substitution here, and you might get powers that are bigger. So you want to avoid to do anything that has to do with parts that increases or complicate the powers that you're trying to obtain. So instead, we're going to go with the substitution u equals the square root of x. Then the du dx is square root of x. Is 1 over 2 square root of x, right? And so that means that the u is actually going to be 1 over 2 square root of x dx. But notice that we don't really have it in there. So we kind of can do something different here, and instead we're going to replace the x by 2 square root of x du. And we're going to find a way of just make it so we have a way to transform anything that is in terms of x to u. So, for example, here, then we're going to get e to the u, and this square root of x, we're going to see it as u, right? And notice that this is 2 square root of x du, but square root of x is u, so this is really 2u du. And so we can replace that here. And now we get a different thing. Now we get twice u squared e to the u. Now we are to a point where we can now do this with parts, since we have a power and then we have an exponential. Okay, so now to do this second part, I'm going to actually go ahead and do the substitution. So I'm going to use w instead of u, and so w is going to be u squared. The w is going to be 2u du, and then my dv is going to be e to the u, and so b is e to the u. So my parts is going to be b times w. Remember that w is taking the place of where usually we have u. So this will be u squared times e to the u minus the integral of b du. So minus twice u e to the u du. And so again, we have as a result something else that needs to be done in terms of parts, and we can go again with the same type of substitution. W is going to be u, and then the w is just going to be 1 du. dv is going to be e to the u, and b is going to be e to the u. So this is u squared e to the u minus, and then u times b, this is u e to the u minus the integral of b du, and then b du will be bw, so it will be the integral of e to the u du. And so at last the whole integral becomes u squared e to the u minus u e to the u minus e to the u plus c. And this minus with this minus becomes a plus. Okay, so now we're in terms of u, but we gotta go back to the original variable. So u squared is going to be x. This is e to the square root of x minus square root of x, e to the square root of x plus e to the square root of x plus c. So this is the final result of this whole integral. So as you can see, we did parts more than twice, even though, and we have a substitution in the middle. So quite a few things. So now for number 9, we have the multiplication of powers of sine square cosine square. But if I try to just do one in terms of the other to get some sort of substitution, it's not going to be easy. I'm still going to have one side or cosine left. So the easier thing that I can do here is to transform this using double angle identities. So for example, sine squared can be seen as 1 minus cosine of 2x divided by 2. And cosine squared can be seen as 1 minus 1 plus cosine of 2x divided by 2. So it's pretty much the same kind of identity. The difference is the sign. And the nice thing with this is that this produces a difference of squares. So from here, this is really transforming into 1 over 4, 1 minus cosine square of 2x. And so I simplify a very complicated integral into something that I can manage much more easier here. And notice that 1 minus cosine square, well, is going to be sine square. So this is just 1 over 4 sine square of 2x. And now, then again, I can use double angle identity again if needed. And so this would be 1 over 4. And this would be 1 minus cosine of 4x now over 2. So I managed to reduce everything in order of a scale, and this is now 1 over 8, and the dx here is going to be x, and then minus 1 over 8, and the integral of minus cosine is going to be sine, or sorry, the integral of cosine is sine. And because it's of 4x, then we're going to get a 1 over 4 out. And this is going to be sine of 4x. And then, of course, the plus c. So the key part here was the conversion of using identities to simplify the integral that I was trying to make. Okay. Now let's go to number 10, which is going to be integral of cosine of 3x sine cube of 3x. Notice that if this will be two different internal parts, we might have to use some sort of double angle identity, but also we have a power here. So my takeaway from this will be, well, let's probably use sine of 3x, and then the du, the derivative of this, is just going to be 3 cosine of 3x. Of course, we're using chain rule, so you got to be careful here. But this is the u, and this is going to be the u, and so this integral transforms the integral of cosine of 3x. Well, actually, I can see it instead as sine cube of 3x times cosine of 3x dx, right? I just flip around the order, and because I need a 3 here to have a du, then I can put the 3 here, and I'm gonna put a 1 over 3 here. Now this is gonna be equals to then 1/3 u to the 3 du, and so this is just 1/3 u to the 4 over 4 plus c. And getting back to the original variable, this is 1/3 of sine of 3x power to the 4 divided by 4. Okay. All right. So now moving on to integral 11. For 11, we have that is x over square root of 3x minus 6. So this is not something that we can really deal with it in this way, like we can simplify or do anything special. So what we're going to do is we want to transform the denominator into something simple that we can arrange. So if we do u equals 3x minus 6, the du is going to be very simple. It's going to be 3dx. And so I can change this into 1/3 of, and then this is going to be square root of u. And I put this 1/3 so I can have the 3dx here. And so I'm going to transform this into the u. And I still have this x here that I want to deal with. But notice that the substitution in terms of u in terms of x, I can also transform this in x in terms of u. So I can write u minus 6 is equals 3x. And so u minus 6 over 3 is equals x. And now I can replace this x by this. So this means that the next step, I can write this as, notice that this is a 3 on the bottom, but this is a 3 multiplying, so it's going to be 1/3 anyway. And now this is going to be u minus 6 over square root of u du. Now I can simplify this again. This is 1/3 of u over square root of u is just going to be square root of u. And minus 6 over square root of u is just going to be 6 u to the minus 1/2. Okay? Remember that square root of u is u to the 1/2. So integrating, this is just going to be 1/3 times u to the 1/2 plus 1. So 3/2 over 3/2. And this is minus 6 u to the minus 1/2 plus 1. So 1/2 over 1/2 plus c. And then of course I gotta go back to the original variable and just flip this around. So this is 1/3 of 2/3 of 3x minus 6 power to the 3/2 minus 12 3x minus 6 to the 1/2. And then of course you can multiply this 1/3 here, and this becomes 2/9. 3x minus 6 to the 3/2, and then minus 4 3x minus 6 to the 1/2 plus c. And so as you can see, this has a lot of substitution plus rearrangement of terms. And so this is a special technique that you can use for certain integrals. Transform the integral to something that you can then simplify algebraically and then compute the integral with the normal rules. Last but not least, we have this 1 plus the square root of x to the cube. And so the integral of 1 plus the square root of x to the cube dx. And so again, the easiest way that we can do this is like break apart what this cube is. This cube by itself is going to be like it will be something that I could do potentially for substitution, but I don't have the du clearly in near. So the most easy that I can do is, well, this is a binomial cube, so it's the first one cube plus 3 times the first one square times the second plus 3 times the first one times the second square plus the second one cube. This is the binomial cube broken. So this will be 1 plus 3 squared of x plus 3x plus x to the 3 halves. And so at this point, we have something that is only in terms of powers. So it's going to be much more easier to do. This is just x. This is 3x to the 3 halves over 3 halves. Remember that x squared of x is x to the 1 half plus 3x squared divided by 2 plus x to the 5 over 2 over 5 over 2 plus c. And that is the last of the examples on these special strategies that we use for integration.